Hello there and welcome to Upper 6 Further Maths. Here we're looking at trigonometry in Radians mode so we can answer questions from exercise 5b. So how do we do trigonometry in Radians mode? Well, we do exactly the same stuff as we would in degrees mode, but just in radians when the angle is in a radians unit. So just a reminder then, we had the angles of 0, 30, 45, 60 and 90, and we expected you to remember the outputs of sine, cos and tan for these 5 individual angles. So just a reminder of what they were. It goes a little bit like this. So you could remember it as 1 over root 2, the root 2 over root 2. This cell here could be 1 over root 2. We'd expect you to remember all of these, but now in radians mode. So if we get rid of the degrees and we replace it with radians, then we'd expect you to remember that sine of pi by 6 is a half, because pi by 6 is the same as 30 degrees, sine of pi by 6 is a half. And if you forget any of these, remember you do have the calculator available as well. Now at the moment, your calculator may not be exactly the same as my one on the screen here, but at the moment it's in degrees mode. And that should always be there for most calculators. Now to turn this calculator into degrees mode, you press Shift and then Menu to select the Setup option. So we'll go to that. Then you want to change the angle unit. You want to change it from degrees to radians mode. So on your calculator, hit number 2, and then all of a sudden you can then select to put it in radians mode by selecting again option 2 to select it in radians mode. And if you'd like to move it back from radians into degrees mode, at this point you just press number 1. So press number 2 and you're there. So let's now have a look at how we might calculate the exact value of cos 4 pi by 3 without using the calculator. Of course, you could just type it into the calculator as well. But 4 pi by 3 along the cos graph would lead you to a point here. So cos 4 pi by 3 will then be an equivalent value if we move pi by 3 along to pi by 3 along symmetrically. The other side will lead us to 2 pi by 3. So cos 4 pi by 3 will be the same as cos 2 pi by 3. It's just by the symmetry of the cos graph. Then, how do we work this out? How do we work out this output value here? Well, symmetrically, it's also going, rotationally symmetrically, it's also going to be equivalent to the other side of the axis on the x-axis up here. So if we just flip the graph and rotate it around pi by 2, it will end up here. So effectively it's now the same depth that it would be on, but we're now going in the positive direction, so it's on the height. So we can now work out what cos pi by 6 is. So to cos pi by 3, because it's pi by 6 distance, cos pi by 3 will be a half, but it would be on the negative side where the original 4 pi by 3 angle was, so the answer there is minus a half. So the answer to what cos 4 pi by 3 is, it's minus a half. And we've just used a bit of symmetry, line symmetry and rotational symmetry to get to this pi by 3 point up here. As we go a little bit more of a difficult one, sine minus 7 pi by 6. So if we grab the whole sine graph from minus 2 pi up to pi, then minus 7 pi by 6 will be just a little bit less than minus pi, just because the fraction minus 7 over 6 is a little bit less than the fraction of minus 1. And if we were to draw a line horizontally across to give us an angle with a similar output, then we would get this point over here. It will be at pi by 6, because the distance from minus pi to minus 7 pi by 6 is a distance of pi by 6, so we'll go up by that same distance on this side to pi by 6. So it's the same as pi by 6, and we know that sine pi by 6 is 30 degrees, so it's a half. And it's positive half here. It doesn't matter that the angle was negative, it's along the top. We only moved horizontally across to something of equivalent value. So this line here would be the line y equals a half, because the output's a half. Alright then, your turn to have a go at these two questions here. Then pause the video. You can always check your answer on the calculator like I'll do afterwards. Okay, let's now have a go at the answer for sine 7 pi by 3. So I'll need the graph for sine that will go at least up to 7 pi by 3. This will be pi, this will be 2 pi, and then this point here will be the point of 7 pi by 3 because it's just a little bit more than 6 pi by 3, which would be 2 pi. Now if I go backwards by 2 pi radians, backwards by 360 degrees, I'd end up at this coordinate here. I've taken away 2 pi radians to get to this coordinate, and that would be at pi by 3. And I know the sine output of pi by 3 is root 3 over 2. I just know that off by heart from a radian calculation. So there we are, that's the answer, root 3 over 2. Moving on to part B now, minus 7 pi by 6. Okay, well I'll need the positive and negative cos graph. So I need it just a little bit less than pi. Minus pi would be here. So minus 7 pi by 6 will be here. Now if I add 2 pi radians onto this, I'll get to this point over here. And that point will be at 5 pi by 6 radians. And then this point here is pi by 2. So if I now just use a bit of rotational symmetry, I'll get the point up here, which will be pi by 6. And then I can just flip it round onto the other side to lead it to cos pi by 6 will be root 3 over 2. But the answer to what cos of minus 7 pi by 6 is it would be minus root 3 over 2. So the answer to this question here is minus root 3 over 2. And I can check these all on the calculator. So grab your calculator. Currently it's in degrees mode, so I'll need to change it to radians mode. So shift menu to get the setup option. Hit number 2 to change the angle unit. Then select radians. And then once you press number 2, you just type in the calculation you want to work out. Boom, got the first one right on the calculator, and the second one, boom, minus root 3 over 2, got that right on the calculator as well. So there we are, that's how we can use the calculator to work with trigonometry in radians mode. Just make sure you've changed your calculator, and you'll always know you're in radians mode because there'll be a small R on the top of the screen, top of your display, on your calculator screen. So there we are. That's answers to exercise 5b. Make sure you have a go at the problems from page 118, and then move on to exercise 5c, where we actually get into some complicated calculations with radians. Lovely. Thanks very much for watching.